So far we have discussed how to build a program that can convert a decimal number to a binary number. Uh, in previous example, actually, we have built this program that can change a decimal number that is smaller than 256 to a binary unit. But let's do it like in another way. Let's say that we have a really huge big number, and then we want to build this program. Do we have to like start copying everything down and like do it like hundreds of times, or there is a simpler way that we can do that? So let's build the same program in another way that is going to take less space and less time for us to build this program. So I have talked about like the if statement, a while loop, and a for loop. Which one do you think can be like the best example here? Like which one of these structures we can use to build this specific program? I'll give you several seconds to think. If you're thinking about for loop, it's a great example. Here we're gonna go with for loop. Why? Because it's a loop. So something happens over and over and over again inside that loop until a specific constraint is met. So for the same example with the 8 slots and everything, the binary numbers, converting a decimal number to a binary number for a decimal number that is smaller than 256. What do you think the constraint is for loop? Like how many times the for loop should run? Exactly, the for loop should run for 8 times, because here you can see that we have done the dividing function 8 times. So the for loop should repeat 8 times too. I'm gonna make this block diagram larger actually, because you know what we want to do. So if you right click in the block diagram, you have to find the for loop in the block diagram, because that's where the programming happens. You're not gonna find it in the front panel. So once you're in the block diagram, right click and go to structures, and then choose a for loop. And then drag and draw a for loop here. So you can see the for loop looks like several pieces of like papers stacked on top of each other. So this is like the graphic for it. It means like several times running a function. So here n is the loop count. It actually shows you how many times you want this to repeat. And here, this is also the loop iteration. So for example, you want this program to, for example, run for 100 times. This I is going to show you this is the first run, the second run, the third run, till the 100 runs. So when this program finish, the constraint for this for loop to finish and be done is when the number of iteration or the loop count equals to the loop iteration. So when the loop counts equals to the loop iteration, that means that the for loop is done. So for example, if you are running a for loop for 100 times, you want to run a for loop for 100 times. So this n is 100, it's a constant number. But this iteration will change from 1, 2, 3 to 100. So whenever the loop iteration equals to 100, which is the loop count, the for loop will be finished and it will get out of the for loop. So for this specific problem, what do you think is our loop count? I'll give you several seconds again to think. It's 8, right? Because you want to run this 8 times. So you stay here, right click, create a constant of 8. You can also create a control, and once you create a control, you will have it shown here, and then the user can type 8 here. But I'll just have it in the program for now. So you want your decimal number as a control here. So if you remember in the previous program, I told you that you can click on your control, right click on your control in the block diagram, go to create property node and then value. And then you will have the exact same control here without having it printed twice in the front panel. So then you'll have it here. You can also like wire it from here to wherever you want in the for loop, but then it's going to be a lot of wiring things involved that you may not like it. So this is one way to have a cleaner program. You can create a property node value of this control and then have it here. And we want this property node that we created to be a read, not a write. So we want it to be a read or a control or a signal that it sends out data. So it's like an input for us. And we want to have in the numeric function palette a quotient and a remainder. But you will put the quotient and remainder inside a for loop because you want this function to repeat 8 times. You don't want this decimal number control to be in the for loop because you don't want it to appear 8 times. But what you want to be done 8 times is basically the function of the quotient and remainder. So that's why you have to keep this in the for loop. So you basically keep everything in here in a for loop. But this should be out of a for loop because it's only one time reading it and the rest will happen inside the for loop. So you will connect this to your x value and your y value is going to be dividing this number to 2. You will create a constant and you'll divide it to 2. And then for the floor or the quotient and the remainder, you'll just connect it to the for loop, the wall of the for loop for now. And I'll explain to you what you want to do. So, so what you did so far is that you're saying that I want this for loop to run 8 times, and I want my decimal number to be read first, and then divide it to 2 8 times inside the for loop. But we'll get the floor, we will get the quotient and the remainder. But how can we tell the program get the quotient and then divide it to 2 again, like we are doing it here, like get the quotient, divide it to 2 again, get the quotient again and divide it by 2 again. How can we tell the for loop to do that? So right now we are having like, we call this like loop tunnels like here, so or auto index tunnels. So these are basically just passing data. So that's all they do. They get the data and then pass it. Get the data, and right now it's passing it to nothing. So you don't want that. You want to get the data, pass it to here, and get the results, get back again here, and then divide it to 2. So you basically want the quotient, the results of the quotient here in the right side of the for loop, and you want it to be transferred back into here and then again divided to 2. And then read it again here, and then transfer it back again here, and next divided by 2 again. So this means that your quotient is going to be divided to 2 several times. So so here we have a square, a filled square, and we have another square that is like a bracket. So that filled square, it means that it's just going to pass the data inside. And the bracket here means that if you have it like a bracket, like a white square with a bracket inside, that means that the results are going to go into an array of data. But we still have this problem that we want the results to go back for the next round and then go back to the next round. Because if we don't do anything to it yet, it's going to just read the decimal number every time for 8 times and then going to divide it to 2 and give you the results. I'll show you what I mean here. So I'm going to create an indicator for the quotient part, just for the quotient part. And then we're going to run this program and you're going to see what I mean. So if we choose the number 64 here, and the number 64 is going to run this, and it's going to run this part of the program too, because we have already created a property node value. So these two are basically the same. And now if I run this, we'll get the correct results for this part. But this part, the quotient part, you will see that you will see 32. This is called an array. So an array is basically not an integer, it's not just a number, it's a vector. It's a vectors of number. And then you can see this by like either dragging it to the top, to the bottom, to have it like vertically oriented arrays, or you can drag them to the right and have them horizontally directed arrays. And you can see we are having 1, 2, 3, 4, 5, 6, 7, 8 elements in our array that they are all 32. You can see that the others, like no matter how much I make them, like I drag them to the right, they are not active. They are all like zeros and they are kind of like sleep. So they are not active. So only the first 8 have been filled with numbers because we are running our for loop 8 times. So you can see that they are all 32. So what does it mean is that, I'll turn on the light bulb here. You can see that it's gonna read the number, the decimal number. Actually, it's gonna finish this first and then go there, which is 64. And just give it a time until it gets there. So it's gonna read 64, come inside, divide it to 2, get 32, and redo it again over and over. So this 64 always stays there. And here in this node, which is the property of this node is to get the signal from here and transfer it to the for loop. That's the job of this node here. It's always gonna transfer 64. And this is not nice. We want this node to transfer 64 at first, but for the next run, we want it to transfer 64 divided by 2, which is 32 here. So I'll just delete this part for now. So what we should do, it's simple and it's so easy. What we have to do is that we have to click this, click on the loop tunnel, and then right click and say replace with shift register. So you replace it here with the shift register. Whenever you have a shift register on the left side, you should also have it on the right side. But the question is, do we want to have it on here on the quotient part, or do we want to have it on the remainder part? Where do you think we should put it? On the quotient part or on the remainder part? On the quotient part, because we want the quotient part to go over and over and over again. So I'll just stay on the quotient part and I'll click on here. You can also grab, you can always like grab it and move it also around. So what the shift register actually does is that it's gonna take the number and then transfer it inside a for loop, get the number and hold it, and then transfer the value back into the shift register again and hold it, and send it inside the for loop, run the functions, whatever functions that are inside the for loop, get the number, get the output, and then transfer that output again inside to the next shift register. So the shift register on the left of the for loop is, or a while loop, it doesn't matter. It's going to be used on both for loop and while loops. So the shift register on the left side of the for loop or a while loop is going to get the number, hold the number, whatever number that is passing through it, is coming to it. It's going to get that number and it's going to transfer it inside the loop. And then whatever functions that are happening inside the loop is going to happen. And then the loop, and then we are going to send the output signals to the shift register on the right side. So which is here. The shift register on the right side is going to transfer the signals towards the edge of this for loop or a while loop back to the shift register on the left. And then so on. So for example, here we're going to read 64. The shift register is going to transfer the 64 inside the loop. And then 64 is going to be divided by 2, and then we're going to have 32 here. So 32 is going to pass inside on the edge of the loop, coming back to the shift register on the left. So now instead of reading 64, the shift register is reading 32. And then 32 is going to be divided by 2, and then we're going to have 16. Because this is a shift register, 16 is going to be transferred to the next shift register on the left, and then this time 16 is going to be divided by 2 to give us 8. And then 8 comes to the shift register here, transfer back to the shift register here. 8 divided by 2 is going to be 4, and so on. So the property, what actually shift register, the job of the shift register is to transfer data between themselves, between the shift register on the left and the right. So the left shift register sends the signals inside the loop. Whatever function that is happening inside the loop will happen, and then the shift register on the right is going to read the signals, and the job of the shift register on the right side is to send the number that it just received to the shift register on the left side. And then left side send that number inside the for loop or a while loop. Whatever function that we have defined inside the loop is going to happen on that number. And then we're going to produce an output, and the shift register on the right is going to read that output it's going to write that output to the shift. That number is going to be written on the shift register on the right side, so it will get that number and then pass it again to the shift register on the left side. So the shift register on the right side sends signals until the shift register on the right side reads it, and the right side shift register is going to send that number to the left shift register. So the numbers are passing between these two shift register. How many times? The 8 amount of times, the number of times that we have defined this for loop to run. So I'm gonna run this one more time with the light bulb, and you can see exactly what it does. So once this part is finished, you'll see how this number here is gonna change every time. So 64 coming here, producing 32. Next time this is 32, you can see that. Next time is 16. Next time is 8, 4, 2, 1, and then 0. So you can see that. So the numbers are actually transferring between these two shift registers. So this is perfect. So we basically programmed the entire thing that we have defined here into one simple code. And you don't have to have like a really big for loops. You can make it even smaller. So now the results, actually what we want, the result of this program is the remainder. It's not the quotient. So all we have to do now is to right click and say create an indicator. And we'll call our indicator binary number. So next week I'm going to talk about this more, but just look at this. Like here, all these lines that we have programmed so far are thin lines. So maybe if it was in like PowerPoint or Excel, I would have said it's like 0.5 pt. But here, this line is thicker. It's still orange. That means that we are still carrying floating point number, but this is thicker. Why do you think that's the reason? It's because this is an array. It's no longer a single integer number. So I'm going to talk about arrays next week more. But as I said, array is like a vector of data. So it's not just one single number. It's a vectors of data that you can either spread them to the right and have them horizontally, or to the bottom and have them like vertically. So because this is a for loop and we are running this like 8 times, we will have 8 remainders, and those 8 remainders are going to stored in an array. Let's run it and then you can see. So I'll click on this, double click on it, and it will show you where the array is. I'll move it down and I'm gonna stretch it. So I will have like my 8 spots that I want to have. 6, 7, 8. And let's run this. So make sure that the light bulb is off. And now let's run it and see what we'll see. You see that this part is running perfectly fine, but this part looks really similar to this, but it's been like reversed. So why do you think it's the reason? The reason is that for this problem, which is running right, the first remainder is going to be our first number spots from the right. But when we are running this part of the program, the first remainder is going to fill on the left side of the array. So the array is going to get filled from left to right. However, for our program in here, the first remainder, based on the binary math and everything, the first remainder should fill the right spot of the binary number. So the only step that is left for us is to reverse this array. So we want to reverse it. So like this way, the 0 and 1 are like 0 and 1 here. So how can we do that? I'm going to explain, and I'm going to talk about arrays more in the next week of the videos. But I thought that it will be really nice if we have a program to show you how the for loops work. And for loops, they are always with arrays because you want to see a set of data. You don't want to see just one number. So there were no way that I could skip the array part for this. But you can see it's not a hard array thing. It's just really simple. So array here is just like a vector that we have filled, and we want to reverse that. So if you right click on the block diagram, there is a palette called array in the programming functions. If you stay on the array and then start reading through this, there's one that is called reverse 1D array. And by the way, we are having a 1D array. It's only one dimension. It's only one row that has been filled with data. And as I explained, we are having a thicker orange wire or line. That means that this is a 1D array. You will see 2D arrays and all these things in the next set of videos for next week. So what we have to do is that we have to delete this wire, and we have to rewire things. So we basically get the outputs of all the remainders into this array function. And what this array function does is that it's just going to replace it. So the further left number is going to be the further right number. So it's basically going to completely be reversed. And then we will rewire the output of that to the binary number. You can click on this reverse 1D function and go to help and read what the help says about this function. It's pretty self-explanatory. It's pretty self-explanatory. So the array comes in and it's going to get reversed. So reverse the order of the elements in array where array is of any type. So here for us, it is like an orange type, which is a floating point type. So yeah, so now let's run this. So 64, look at these results and see how it's going to change. Now it's been reversed, and these two are now similar. Do we want to have these LED light bulbs too? I guess we do. We want to have that. So how can we do that? We have to create an array of LED light bulb. So how can we do that? We stay in the front panel this time, right click, you see we have an array here too. Choose this array here and then put it somewhere here. And then stay inside and say right click, this time go to Boolean and choose around LED. So what we are doing is that we are going to fill an empty array with Boolean LED light bulb. As simple as it is. We first create an empty array, which the array doesn't know what is inside of it. It can be numbers, it can be booleans, it can be strings or text. Here we choose booleans. So we create an empty array and we're going to fill it with a boolean. And now if we select the whole thing and start stretching it, you'll see arrays of Boolean, and we need 8 of them. So we have to wire this to something, because this is just an indicator that user can see in the front panel, but it has to be wired somewhere in the block diagram so it will produce results and outputs. So we have to go to block diagram again, and the array is actually put somewhere in here. We will take it out, and where do you think it should be wired to? It should be wired somewhere to here. But this is a number. We cannot wire a number to a Boolean. We have to have one of these functions, whether this is equal to 0 or not. So you remember where we found it? In the comparison palette and here. So we will do the exact same thing that we did here in here. So we're going to get our arrays of 0 and 1, and we're going to compare each element of that array with 0, and we're going to produce the output as a true or false, or turn off LED light bulb, or turn on LED light bulb. Make sure that the size of these two arrays are the same. This is important, and here they are the same because we have created arrays for 8 elements, and here we are having 8 elements too. Actually, it doesn't really matter because it will check reads the 8 elements in the floating point part, and then it's going to compare it to 0, and it's going to produce 8 true and false, or turn off and turn on. Turn on and turn off, actually. So yeah, and you can see again, this is thicker than this. That means that this is a 1D Boolean rather than just a 1 Boolean by itself. So now our program is finished. So now let's run it. See, the results are exactly the same, and you can play with, you can type different numbers and compare the results with each other. So I personally think that this is a way better way of programming, like this part with the for loop, because see, it's so clean, it's self-explanatory, it's easy. It only took 2 minutes of my time to program it, without me talking and explaining it actually, rather than here that you have to have a lot of wires and go step by step and make sure that you don't mistakenly wire something to another thing which it shouldn't be wired to. So you just have to be really careful for this part, and if you're having a lot of them, it's going to get really complicated. But this way it's way cleaner, and you can always come and change this number. So I can type 10 here, and this time I can have a larger number than 256. So I can, for example, have 300. Don't look at this part because this is not a correct result, but this will produce us a correct results. I'm gonna run this, but I have to make sure that I stretch this and increase this and give more elements to that. You will see that these elements hasn't been used because it's 10 times. I already explained 10 times because 2 to the power of 10 is 1024, and as long as I go below this 1023 for the numbers, I should be fine. And I already chose the number 300, so I'm fine with 10 spots. So I'll just run it with 10 spots. Actually, yeah. Actually, a 9 spot is also enough. Yeah, let's run it with 9 spots because 300 is below 516, which is 2 to the power of 9, I guess. 518. 2 to the power of 9 is 518, I guess. Sorry, I'm just getting confused. 512. So 512. So 2 to the power of 9 is 512. So any number that is below 512 should be fine. So if I'm going to choose 300, 9 is enough here. So 9 spots are enough. Ooh. So you have to select the entire thing, and then you can drag it and make it smaller. So choose the entire thing and then make it smaller. So now if I run it again, this is the right number for the 300. So yeah, so this is what I want to tell you, that you can use a for loop for this specific problem. For loop can be used, and just make sure that whenever you're programming it, this 9 or 8 or 10, it depends on like what range of numbers you're going to type. So the number range that you're going to type has to be 1 unit below 2 to the power of n. So if you're going to go with 10 spots, so your number should be below 2 to the power of 10 or equal to 2 to the power of 10 minus 1. So something like that. So for 8 spots, our number should be below 256. So from 1 to 255, it's okay. If we're going to go with 9 spots, we can go to the number up to 511 and so on. So this was a way of explaining for loop. So far with these two examples, we have learned how to use different functions in LabView. We have learned if statements or case structures. We have learned of while loops and for loops, and we have learned the sequence of structures happening with different like mathematics functions and some text files. So I hope you guys have learned enough with these two examples. See you in the next video.